Hey guys, so welcome to our session. This is best practice from the trenches. This is all about workspaces. What you'll find from this though is a lot of the session is about everything around workspace. We don't really cover the workspace, and we'll go into that a little bit later. So my name's Justin Bradley. I'm a specialist for workspaces. I'm based out of EMEA. My colleague Jeff.
Hi, I'm Jeff Ferris. I'm an AWS Workspaces specialist based out of Austin, Texas. I've been in end-user computing for a long time. It was a natural progression for me to get involved with this service. In fact, I even proposed to my wife in a book titled Windows 2000 Deployment and Desktop Management, and I thought that was a reasonable thing to do.
And she still married you.
No one was as surprised as me, right? So what we're going to cover during this session, we're going to talk to you about the best practices for deploying workspaces in really any size environment. We're going to cover a lot of the things that are around the Workspaces service, right? Things that are considered outside of the core. This is a 400-level session, so we're going to move rather quickly through a lot of topics. We'll be talking about the base account structure, Amazon VPC design, and your public endpoints used for the Workspaces service. We'll go into the directory services and integration with on-premises Microsoft Active Directory. And we'll talk about configuration changes to the Active Directory connector, including things like enabling multi-factor authentication. What we will not be talking about is custom imaging, bundles, a lot of the core things around like provisioning an actual workspace. So these are important concepts to cover when you're planning your design for your Workspaces environment, because they're very difficult to go back and change later. So we want to make sure that you're enabled to get these things set up and configured correctly at the outset of your experience with Amazon Workspaces. So with that, we're going to go straight into building a productive environment. The scenario that we're starting from is a relatively common scenario. We have an existing AWS customer, the hybrid architecture, a mix of applications on-prem in the cloud. They're currently using Active Directory for their identity. They have some standard scenarios. They want to be able to support bring your own device models. They want to be flexible for mergers and acquisitions. They want to support mobile workers, people who are traveling or working from the home. And throughout all of it, they want to make sure that user data remains secure and highly available. Now, these are foundations of the AWS Workspaces service. As far as sizing, we're looking at an environment of about 2,000 plus users. Again, we want to leave room for growth. But I should note that this is a common architectural pattern. It doesn't matter if you're a small startup or a large enterprise. A lot of the concepts and key things that we're going to discuss they're going to apply across the board, regardless of your infrastructure size, if you're hybrid or if you're all in on the cloud. Okay? So here's our starting architecture. The customer data center, the customer has a 10/8 network. They have a direct connect, connecting them to their Amazon environment. We have applications in separate VPCs, but everything right now is a single account. So their AWS address space is 10.10/16. Again, everything's connected through Direct Connect. So let's see what we'd recommend in terms of changing the AWS account design and direct replacement models, things like that. So we're going to start with the account structure. What we would generally recommend for any environment is an account structure that takes advantage of multiple AWS accounts. This gives you the concept of administrative isolation for your different environments. Now, whether those environments are separated by environment type like dev and prod, or if you do things like legacy apps in one VPC and cloud-optimized apps in another VPC, or if you break things apart by departments, HR in one directory structure, finance in another, you're generally building these things out to enable that administrative isolation. So we're going to recommend, in any case, whatever you're using for your logic, that Workspaces exists in a separate account. As you can see here, we also have a shared services account. We're connecting that with VPC peering back to all of our accounts. That's giving us access to common core services like Active Directory, MFA, ADFS. Really, anything with an acronym you can throw right into that shared services bucket. Anything that you need access to from those other accounts. The key thing is we're recommending Workspaces as a separate account, and you need to implement consistent tagging standards across all of your accounts. As you can see, we've got the S3 buckets for all logs flowing up into the payer account. Now, the payer account has no EC2 instances in it. It is just those control buckets. You're filling all the logs up that way, and with a consistent tagging standard, you'll be able to go through your billing report, your detailed billing report, and make sense of it, right? But that standard has to be consistent across everything. All right. So as with most Amazon Web Services, the Workspaces service does support IAM policy. But the service is a little bit bigger than just Workspaces. You're going to need to grant access to Workspaces, directory services, and some read access to key management services. We have 3 managed policies that apply to these environments, Workspaces admin, the WAM admin, and directory services full access. But most of the time, you're going to want to create some customer managed policies to give granular access that kind of breaks it out a little further than what we do. And some examples of that, oftentimes you'll have your L1 help desk able to initiate reboots for your customer workspaces. So they're just going to need access to reboot, right? They don't need the workspace terminate permission. Perhaps for your create events, your workspace creates, you don't actually want administrators involved. You want to handle that through a service catalog. So you would use your EC2 roles and a role enabled for workspace create and take humans kind of out of that mix. But then terminate's a destructive action, right? If you terminate a user's workspace, they've lost all their data. So you don't want that to be something that your L1 is necessarily going to use as a troubleshooting step. That should be something that you escalate to your engineering or your L3 or some control point so you have a common known set of operational practices before you initiate a workspace termination. All right, so the key takeaway, use a dedicated account for your Amazon Workspaces deployment, right? Control and restrict access to your workspace account via IAM and implement those consistent tagging standards. With IAM, you can restrict permissions to grant least privilege, and we really recommend that you do that. And with a multiple account model, you have the ability to take advantage of assume role so that you can affect tasks throughout your account structure with the assume role functions. All right, with that, we're going to get into some of the network design considerations, and I want to hand that off to Justin because I like to make fun of the way he says routing.
It's routes.
Route.
Routes.
Route.
So like I say, he may have to translate a few things for you guys for me, right? We just speak a little bit different over the pond. So from a network design consideration perspective, what we're looking at here is how big am I? What do I need? How many IPs? How many workspaces do I plan to deploy? Now, these are all kind of key conversations and questions you have to ask to kind of work through your network design, how you need to build this, right? So if we look at this, we kind of have 3 golden rules, very, very high level, right? So eliminate IP space, be frugal with what you use. Now, what do I mean by that? Well, the largest AWS VPC you can do is a /16, which gives you 65,000 addresses. Okay, so that's 65,000 workspaces. It's pretty big, all right? But just remember, in our example, the customer has only allocated a /16, and they're already using this, so we need to kind of carve it out a little bit more. So do you care about IP space? Well, what I mean here is, so if any of you were here last year, and you saw some of the sessions like on how Amazon.com is deploying workspaces, you'll see that being as large as we are running constant IP reclamation projects to kind of pull back IP address spaces, right? So we don't have as much available anymore. So how do we do this? What needs to be done? Well, if you're a large enterprise in the same space, this is very, very relevant. If you're smaller, not quite so relevant. But again, you need to decide how big you've got to do these, right? Remember, every subnet that you create, and here it says you need 2 of them, right? The reason you need 2 is because directory services that underpins it requires 2 subnets. Now, those subnets, we're creating a highly available infrastructure. Therefore, we're across 2 availability zones. So remember, VPC spans the entire region and every availability zone in that region when you spin it up, okay? So every subnet will cost you 5 IPs. So, obviously don't go and create something really small. I mean, the smallest you can create is a /28. Not really going to help you here, right? Because a /28, I think it's 14 addresses and 5 are lost, so I've got 9, right? So again, I can't split that into 2. I need 2 subnets, okay? So what is your end state? How many users do I have? So our use case was 2,000 plus, right? So we know the initial is around 2,000. Now, what is that plus? Is it 500 more? Is it another 5,000? Over what timeline? So these are the kind of questions you've got to ask around how to design this, okay? And also, how many regions are you using? Are you deploying this in multiple regions, okay? So think about this. Be flexible on what you don't know. Now, what we mean by that is expect new blocks. Now, nearly every customer engagement I've been involved in so far, once you hand a workspace out to the users, and people get more aware that it's there, you'll find that you'll get more and more users wanting to have one. So you will find that things start to grow, okay? And again, think about reserving IP space for additional systems. Remember what I said, the Active Directory connector, and we'll go into details of that shortly, also takes IP space out of the same subnets that your workspaces are running. Okay? So let's kind of move on to what this looks like. So just as a recap, remember, we need 2 subnets minimum. We're looking to avoid IP burn. We have an initial 2,000 workspaces plus room for growth, right? We know what the IP space has been allocated. It's a 1010/16 for the entire AWS. And in the example that my colleague mentioned, they're already deploying applications in the cloud, so some of that space has already been used, okay? And there is a concept of what we call a shared services VPC. Now, irrelevant of whether you're doing workspaces or not, if you're running multiple accounts, specifically in Windows areas, and you're running multiple accounts, multiple VPCs and applications in the cloud, you will at some point have some kind of shared services VPC where you're doing common services, directory, DNS, maybe some monitoring platforms, additional stuff, SCCM for patch management, deployment of applications. You don't really want to be deploying these in each of the different accounts. You want what we call a shared services account to peer things across, okay? So with that in mind, let's take a look at how this would look network-wise. So if we think about this, a /21 network space will give me 2,000 IPs. The obvious question is, that meets my requirements. Yes, I've got my 2,000, but not plus. So I can't, there's no growth on this. Okay, so it's too small, doesn't allow for growth. And what about the next one up, or the next one down, depending on which way your maths goes, right? So /20 is a fourth, that gives you 4,000 addresses. Okay, this meets the requirement, allows for growth. Let's think about this, right? So what does the next one up go? Okay, this gives us 8,000. So remember, everything's a factor of 2. Okay. Well, this, to be honest, is way too large, right? So we said the initial is 2,000. Don't really know how far we're going to grow. But a /21 is too small. /19 is too big. So the ideal place here is a /20, which gives me 4,000 addresses. Now, before we go into how we've split this and how the VPC would look and talk about pod design and architecture, have a little reminder here, right? A /20, so for those who don't know, we're doing maths here, right? /20 gives you 2 21s, right? So I can put it into 2 blocks of 2,000 addresses, or I can split it into 4 blocks of 1,000 addresses. I can obviously go down further down the line. So this allows us to kind of split that network architecture into pods. So do I want to do everything in one subnet range? Do I maybe want to go and do, I don't know, let's say a couple of hundred in one pod, and then I build the next one and build the next one and iterate, okay? So in terms of this architecture, this is kind of what we built as based on this design, so on the scenario we had. So the initial use case was for 2,000 production. So what we've gone ahead and done is we've gone and created, as you can see here, 2 subnets of a /22, which then gives us our 2,000 IP spaces, right? So 1,000 on each side of the availability zones, okay? This now means that I've got my production network. And of course, I've got a lot of additional space left over. Again, I can do exactly the same. I can create 2 more /22s or smaller if I need to. The advantage of this approach means that I've got a production environment, and now I can actually spin up a development environment for my desktop admins. I want to test out specific applications, specific systems. I don't need to do that inside the production environment. Remember, there's IAM policies. I can be very prescriptive in those IAM policies and deny access for spinning stuff up and making changes to that directory, to those subnets. So I can specify the dev only happens below. Okay? And as you can see on the right-hand side, we have what we call here VPC peering. So this is our cross-account VPC peering. Remember the best practice, a dedicated account for workspaces. Okay? Remember, your desktop admins are not your server admins, right? Do we really want to give server admin permissions to a desktop user, right? So be careful of how you do this. So you're all going to get copies of these decks later on anyway. I think we're going to publish them, and then there's obviously the video. But here you can see, so we're talking about Windows. So here we're using PowerShell, so it's the PowerShell commandlet. So if you were doing all of this programmatically, here's how you go ahead and create an account peering. So you can go ahead and create a peering connection. You're selecting the peering account owner, the different VPC sides, so the left side, the right side, and binding them together. And of course, on the other account, you go in and you approve it. It doesn't really matter which way around you do this, whether you're doing it from the shared services account or the workspaces account. You just have to remember you do one as a create and the other side as an accept. Okay. So we're going to kind of go through and demo some of this after the directory section, so bear with us for a moment, right? So on the network design, just some closing notes here. Size your VPC accordingly. Remember that you lose IPs per subnet, so don't go too small, okay? Remember, you need to adjust the routing for peering.
Route tables.
Sorry?
Route tables.
Route tables? No, route tables. So remember to do the route tables inside your VPC. Yeah? I need to be able to route across those VPC connections. Okay? Remember, you've got to allow for growth, right? And VPC peering is your friend. Yeah? Remember, when I fire up a workspace, it will live in one of those VPCs. Okay? So let's kind of move on to directory services. Okay, so we've kind of done a little bit of networking. We've done the account setup. We've got a design that meets our requirements around a VPC with a pod-based architecture. Now we're looking at, well, what do we need to do for directory services? Remember, we've got a shared services account, and there are some infrastructure in there. Okay? So before we really kind of move on, it's kind of different to the previous sections. We kind of have to give you a brief refresher on workspaces and the requirements around directory services. So the first one is a directory is a directory server instance, yeah? So when you create, in this case, we're talking about AWS Directory Service and the AD connector. This is two EC2 instances. They reside and live in the same availability zone, in the same subnet as your workspace, okay? A workspace, as we said before, is tied to exactly one directory. So if I have a user who wants more than one workspace, they can do this, but you need to have two directories. I can only ever have one user per directory. Okay, so the way around this, if I need to have two workspaces for the same user account, is to use two different ADCs, okay, Active Directory connectors. So from a high-level conceptual view, here we've kind of drawn up what we're looking at, right? So on the right-hand side, you can see the shared services VPC, which lives in a separate account to workspaces. This one here has got, again, split across availability zones. There is a pair of EC2 instances, which the customer has gone and installed Active Directory onto, okay? Right. We're using cross-account VPC peering to the workspaces account, where we're able to configure workspaces, and we're allowed the communication from Active Directory connector and the workspaces to connect to that directory. So just as a quick refresh here, the directory components we're using in this design, okay? We start off with Active Directory on EC2. Okay? It's owned and managed by the customer. The customer owns those EC2 instances. Okay? It's used to extend the customer's directory to the cloud. So what we're talking here is, in this scenario, that the customer has extended their forest into AWS. So they've deployed an additional pair of domain controllers. Okay? And we're using the Active Directory, AWS Directory Service directory connector to connect to that service. Remember that the AD connector is a proxy. Okay? Nothing is cached. We push all the authentication is pushed through to go and get a TGT ticket. Okay, so it's all Kerberos based. Okay. If you really want to learn a little bit more about how exactly the communication works, how the flow works with OAuth, with TGT tickets, etc., there is a white paper online that will point you to this. Okay. So one of the key things you've got to remember is, on the previous slide, we showed you the shared services VPC. There was a pair of EC2 instances running Active Directory. Around those Active Directory controllers, there is a security group. Remember, we have to add firewall rules, okay? So remember, there's two components. There's workspaces and Active Directory connectors. Now, the Active Directory connector does not need as many ports as listed here. However, remember what I said. Active Directory connector lives in the same subnets as your workspaces. You need to enable all these ports from workspaces, okay? When you fire up a workspace, it's a DHCP address, so it could end up anywhere. So from a security group perspective, you need to assign all of these ports, allow ingress for the entire range, okay, for your workspace. Now, if you want to kind of reduce the amount of rules that you're creating, of course, if you're using a contiguous space, so my AZ1 and AZ2 and a contiguous IP space, then of course I can summarize those together. Okay, so if I had two 22s, I can do a 21. Okay, so I can round them together and basically put a single rule. Okay. A lot of security guys don't like this, but unfortunately, it's Microsoft, and Microsoft always needs the RPC high ports. Yeah? Otherwise, AD does not work. Okay. So one of the things that we see, and this is why we have this on, so Active Directory sites and services is key to the correct operation of any Microsoft workload in the cloud or on-premise, to be fair. Okay. You're going to be very, very careful. So I've seen this a lot where applications have been deployed in the cloud, directories have been deployed in the cloud, everything's connected. And then what you find is that your infrastructure in the cloud is authenticating not against the local, but sometimes against the domain controllers that are on-premise. This has an adverse effect that it's you'll find that login times slow down, that, you know, that it's kind of odd. I mean, it makes no sense. You really want to be authenticating local. Now, the key around this is that most people forget this, and it's just true. I mean, I've done this myself, right? Is that when you set up a new site, quite often people forget about Active Directory sites and services. So if you set this correctly, right? So I build Active Directory sites and services. I create a new site. In this case, I call it AWS, and I'm using the region code to kind of define it. Then I'm going in and specifying the subnets inside of this to make things work. So you can see this. And then we have a replication cost, so we ensure that replication happens in the correct method. So let's actually flip over to the demo, and we're going to kind of run through how this looks so far. Okay? Yep. So let's start in the console. Okay? So in the console, we have, as you can see here, we've created our own VPC. Okay? So we've pre-created a lot of this because it takes quite a bit of time to set up this level of infrastructure. Okay? So a lot of this is done with CloudFormation. Some of it's done manual, but ultimately, you can automate all of this process. Okay? So we have our VPC created for the shared for the workspaces. We now have what you can see here, the first two subnets. So you can see a pod 1, right? So we've labeled them. Remember, tagging is key. Okay, so the first two subnets are our production. You can see we've allocated. This is a little bit smaller on here, but in terms of the design, this will be our /22 networks. Okay, and as you can see, we've created a couple of additional ones. So you can see a pod 2, and we've called it dev. So if any of you have been downstairs to the booth, you will see that we're running Workspaces demos down there. That is running out of that dev environment. And we have very restrictive IAM policies, so they cannot delete, well, this stuff we're about to show you, right? So this is kind of the approach, right? So we have our production where we're working on, and then we have another set of teams working on different things in a different pod. Okay? So if we look at the peering connections, so you can see what we've gone ahead and done is we've gone and created a peering connection between our workspaces and the shared service account. Remember, all of those workspaces and ADCs need to be able to communicate, okay? So this happens across the peering. Now on this, you can see a second one. This is the workspaces on-premise. We're having to simulate the Active Directory, so the direct connect. So typically, you're going to be having a virtual private gateway connecting, so all your VPCs will connect. Okay? We'll show you that a little bit later on. Okay? So remember, as I said before, in the routing tables, so you need to go in here into the routing tables and make sure you go to routes. Yeah, go to routes. So you see here, we've added the specific routing to enable that communication. So just setting up the connection means I've got a peering connection, but you still have to do the routing associated with this. Yeah. Okay. So now let's kind of flip over to Active Directory. So we kind of cover the networking, we cover the routing, and moving things forward, right? So let's take a look at what this looks like inside of Active Directory. Remember, sites and services is our first point of call here. So inside of sites and services, you can see what we've done here is we've created a brand new site. Can you zoom in on that?
Nope, hang on.
Oh, sorry, bear with us. So what we've got here is we've gone ahead and we've created a new site. We go there?
There we go.
Yeah, so we've gone ahead and created a new site. That site we've labeled AWS, right? But what you can see here, we've actually labeled this with the region code. Remember, if you're using multiple regions, you need to kind of differentiate between them. If you just call it all AWS, it's going to be fairly confusing, right? In addition to that, we've gone ahead and created the subnets. Here you can see we've specified the subnets that are associated, or the CIDR blocks that are associated with the cloud. In this case, the 10.10.00/16, which was allocated by the customer for AWS, is what we've allocated to the site, as you can see here, site AWS. Doing this ensures that when I log into a machine, or I'm doing anything on that server, what will happen is it will always authenticate local. The only time it will go across the wire to the other ones is if, for whatever reason, the directory is not available. Okay. So let's kind of pop on over back to the. Let's go into the edge. Yeah. So let's take a quick look at what we're doing inside a directory. Right. So one of the things we see here is most customers, and I'm guessing yourselves as well, have a specific OU structure associated with your desktops, okay? So your desktop fleets. When it comes to Workspace, we recommend you create a separate OU under that structure. And the reason for this is all around group policies. You want to be able to define different group policies based on what you're using, okay? And under this, you can see we've created an additional one called US West 2. So we're linking this back to the region, okay? Now this is really good because as we're doing it this way, it means that I can now go ahead and create group policies that are specific to region. What happens if I'm running I'm running different proxies in different locations, different settings, okay? So one of the things that ADC requires to move forward, okay, is you have to create an account for the Active Directory control connector to be able to authenticate against AD. So you can find and do the Kerberos lookup, Kerberos TGT tickets, and authenticate the users against a workspace. Yeah. So following best practice, what would Microsoft say? Well, go ahead and create a global security group inside of your AD, put the user you've created for ADC into the group. Now, what ADC requires is a couple of permissions. Okay? It needs to be able to read the directory, so it needs to be able to read all the user objects. But it also needs to be able to create computer objects inside of the directory, okay? Remember, it needs to create. Now, typically, you're not going to want to have it be able to create it anywhere in your domain, okay, or anywhere in your OU structure. You want to limit it to a specific location. And in this case, you can see what we've got here. We have create computer object. It's not inherited, okay? And it's from this object onwards, so it's from the Workspaces OU down, okay? And you can see here as well that we've got read all properties, and you can see here it's descendant from user objects. So we've given it at the top level, it can read the domain. Okay. So let's flip over to the console, and we'll talk about the Active Directory connector and actually setting this up. So I'm going to hand over to my colleague to cover this section.
All right, so for this part, we'll actually go into the Workspaces console. Up under directories, as we mentioned, it takes a little while to create an Active Directory connector, so we've kind of pre-baked the pie here, Martha Stewart-style demo, right? We've already created the Active Directory connector, but it's not yet registered, so that part goes relatively quickly. Select, register your directory here. Now, what we recommend is that you do not enable Amazon Work Docs on the Workspaces directory connector. You need to create a separate directory connector for Work Docs. We'll show a little bit of why that is later, but the organization name when you create a directory is globally unique. So for Work Docs, you want to have a consistent directory for all of your users, but you may actually be partitioning out different capabilities or different groups of users in the actual Workspaces service. So we're going to say no there. We'll click register. This generally goes fairly quickly. There we are. And you can see here the actual details of the directory. Select Actions, Update Details. This is where we're going to look for the OU that we created earlier. So we'll search, list all OUs. We're building this in US West 2, so we're selecting the sub-OU for West 2. Highlight that there. And again, that's just to make sure that your Workspaces accounts are created in the right location in your Active Directory.
Yeah, so just a little note on that one. If you don't do this piece, because we've only allowed permissions in that OU as we did on the previous step, workspace creation will fail. So you have to make sure whatever you set inside of your Active Directory and your OU structure matches what you put here.
Right. So security groups, you can add an additional security group beyond the default Workspaces security group to all of the workspaces in a directory. You would do that through this button here. And then access to internet. Generally, we're going to recommend that you leave that disabled because most enterprises are going to want to route the internet connectivity through existing network connections that they have. At the very least, you'd want to build a NAT service and go out over the IGW via the NAT. By not giving direct access to workspaces through the directory option here, you can also put things in place like a Sophos or a Palo Alto Networks device for content filtering. But if you give direct access to the workspaces, it's going to create an IGW, give each workspace an elastic IP, and that's generally not something that you're looking for. Maybe an environment where that would be necessary, but generally there's not. All right, web access. We released this service just recently. You can enable this for the entire directory. This actually lets you connect to your workspace from the web browser. So instead of needing the standard Workspaces client, you can now get to it from an HTML5 enabled web browser. Excuse me? You can enable it after the directory's been provisioned, but as with most of the changes in this part of the console, if you make a change to one of these directory settings, you'll need to either rebuild a workspace or otherwise affect that configuration. One of those options would be here on local administrator setting, for an example. If you've enabled that option for your entire directory, then by default, when you create a workspace, the user account will be pushed into the local admin group on that workspace. If you later realize that you didn't want to do that, you can use standard Active Directory mechanisms, standard AD tools, to pull the user out of that local administrator group. So there are some things you can change afterwards, but a lot of the options are directory level. Web access is one of those. So just a quick show of hands. How many people here restrict their local users from having admin rights? Right? And how many of you give yourself admin rights anyway? Yeah, I thought so. All right. So if you need to change the AD connector account, you can do that through here. If you're rotating the password, this is an area where you could make that configuration change. You want to make sure that you're well coordinated if you're expiring the password for your Active Directory connector, because during the time when you're waiting to re-authenticate, if you've changed the password, rotated the password on that service account, your users won't be able to connect. Here's where you can go in and make those types of corrections. Multi-factor authentication, we'll talk about that a little bit more in detail later, but this is where you enable it. It's either globally on or globally off for the entire Active Directory connector. And then maintenance mode is a relatively recent setting that affects the what do they call it? Auto-stop desktops. So if you have hourly desktops, this is where you can make sure that they come up at least once a month for a 3-hour period to take patches or software distribution, whatever, to check into the network, update their Active Directory accounts, and do all the crazy things that Windows systems do if you've left them idle for a long time. All right, so we're going to cancel there.
Okay, just flip the screen.
And back to the slides.
Yep, back to slides. So don't worry, we'll be back into the console and things very shortly. So yeah, so if you think about it, what we kind of do as part of the closing now is we've done the account setup, we've done the networking, right? We've looked at what needs to be done. So we've required, so for example, Active Directory connector. To use it and to run this correctly, you need to have the functional level must be 2003 or higher. The majority of people are probably running this now, okay? Don't know many that aren't, to be fair. You want to create a dedicated Workspaces OU, yeah? So you can differentiate between group policies. You want to create a global security group and then add users. So remember, you can have more than one Active Directory connector as you go through. So there are multiple use cases. For example, as my colleague mentioned, and he's going to cover this in a little while, MFA, it's global on for the Active Directory connector. If I need to have different settings between different groups of users, I use different Active Directory connectors to achieve that result, okay? Again, this all comes back down to the global security group. Ensure that this has got the correct permissions. Remember, it needs to be able to read the domain. And it also needs to be able to create computers, okay? So the key one here is, and actually this is the one that I really can't stress enough, is Active Directory sites and services is key to the correct operations of everything here. Most times when it comes to authentication issues and so on and so forth, it's down to this more than it is networking, okay? And again, like I said, use the Workspace OU group to apply group policy specific, okay?
All right, so in this section, we're going to walk you through the process of importing the PCOIP.adm template to your Active Directory, as well as configuring the encryption level, making some changes to clipboard and printer behavior. So now that you've connected your Active Directory, created your OU for Workspaces, you can customize group policy for those workspaces. On every workspace, we include a PCOIP.adm template. Again, you'll be able to see these slides later, so you don't have to frantically write this down. It's in the same directory in all the workspaces, and it's used to control features such as local printer support, clipboard redirection. So you can decide, do you want the users to be able to access a shared clipboard between their outer shell and the workspace? Do you want to limit the users so they can only use the clipboard inside of the workspace? Or if they didn't get you anything nice for sysadmin's day, you can disable their clipboard altogether. So this is also where you can set things like the session resume timeout, and one of the options that we generally recommend changing the configuration for the streaming encryption protocol. So we'll go back to the group policy management console here and actually show what that looks like. So here we've already imported the policy template, but just as a reminder, if you did need to bring it in, right-click, go into, let's see. Well, yeah, it's in here. You right-click, you bring it in through the administrative templates section. So as we drill down into computer configuration, policies, administrative templates, to bring in that PCOIP ADM template, you'll click Add Remove Template, and navigate to the location on the device where you'd find that template file. We've already brought it in here, so we go into classic administrative templates, and within there, PCOIP session variables. And we're going to go into the not overridable administrator settings. It seems somewhat obvious. You don't want users to be able to override the things that you want to enforce here. So as we go down, we'll see the PCOIP session encryption algorithms is enabled. So in the details of this policy, you'll see a couple of different options. It's a bit of a double negative on the way that this group policy template is written. So by default, session negotiation is going to fall back to the lowest common denominator. So if you've left multiple encryption algorithms selected or enabled, say you have not disabled AES 128, by default, your workspaces are going to negotiate down to that lowest common denominator encryption. So by ticking the box in front of the policy to disable those configuration options, you want to leave just the AES 256 GCM encryption option open. That will ensure that your entire PCOIP session is using AES 256-bit encryption. Like I said, it's a little bit of a double negative, so read the policy closely. When you're in there, you're going to disable the boxes in front of the protocols that you do not want to use. Now, there's a lot more that you can do in this policy template in terms of tuning the performance of the overall PCOIP protocol, but for what we offer out of the box, it's going to work for the majority of your Office use cases. If you did have some special use cases with higher video updates, things like that, you could go in here to further tune the PCOIP protocol. All right. So just kind of to recap on group policy, the template file is available on all of the running workspaces. That's where you're going to find that template to do the import. You should create a default Workspaces machine GPO and apply your minimum required settings that are common to all of your workspaces at that level. You can also break things out by regional levels for other areas where you need configuration changes in the structure that we showed with our OU design. Any changes that you configure are going to be reflected on the local system in the PCOIP arbiter log, and they'll appear as management environment settings in that log. We'll show that a little bit later. And our recommendation, of course, is to disable all encryption protocols except AES 256 to ensure that you have the highest security channel available. Then again, if you do need to do further tuning, you can do that in the same place. All right, so now we'll talk a little bit more about multi-factor authentication. We showed where it was in the console earlier, so I've just pulled a screenshot up for it here. So if you want to add an extra layer of security, and for pretty much everything you do, maybe not labs or shared kiosks or systems with shared environments, you really should enable that extra layer. You'll want to enable multi-factor authentication. So MFA is enabled in the ADC configuration. What you see here is the screen from that. You just need the IP addresses for your Radius servers, and you need to know the base configuration for the shared secret, the protocol, and the port that you need to use. Now, we always recommend using multiple Radius servers for high availability. You can comma delimit the addresses for your Radius servers when you enter them into this box, but what that means is everything else you'll notice is not comma delimited. So all other options in your Radius configuration need to be identical. You need to use the same shared secret, you need to use the same communication port protocol, and your timeout is going to be configured identically. So the maximum timeout that we currently support is 20 seconds, and that, for pre-generated keys such as a hard token or a TOTP, time-based one-time password algorithm, you can set that value fairly low. Because the user is entering it before they actually submit the login request. But for any out-of-band second factor, for things like an application push, you should set that to its maximum 20 seconds. That gives the user time to pull out their phone, fumble with it, forget how to unlock it, hit the buttons a couple times, and frantically stab at the accept button for their app. They're going to need time to do that. So 20 seconds is the maximum that we currently support. So again, you enable that at the Active Directory connector level. That means everybody in the directory is either enabled or disabled. The security group must allow traffic communication on 1812 in the instance where we were showing port 1812 for the MFA server. It must allow that communication between your ADCs and your Radius servers. And we support a variety of products from our partners. You see a couple of them up here. Symantec, Gemalto, Duo Security, Okta, most general Radius solutions. But the key thing we want you to remember, provision multiple Radius servers to increase availability. You hear this time and again in Amazon, put things in multiple AZs, put things in multiple locations. That's going to increase your availability of the service in general. Your Radius servers can be on EC2, or they can be on-prem. It doesn't matter. You just have to be able to route to them from within your Workspaces subnet. And then you can implement different radius standards through the use of multiple ADCs. So if you have a training environment and you don't want to require MFA because there's no proprietary or confidential or concerning information there, you can leave MFA off by creating another ADC for those users. By the same token, let's say you're currently using Gemalto hard tokens and you want to pilot the use of something like Duo security in your environment. Create another ADC and change the configuration of your Radius server there, give your admins access to those workspaces to do their tests. All right, and with that, let's recap a little bit about the communication flow for end clients. Now, anyone who has sat through any session with a solutions architect has probably seen some variant of this diagram. This shows the actual traffic flow between the Workspaces client and the workspace itself. So the key things that I want to highlight here are the multiple accounts. We have a AWS managed account in the top section. We have your customer managed VPC in the lower section. Workspaces exist in a management account. You won't see them in your EC2 console. You will only see their ENI. They're one of their network interfaces. So in your VPC, you control the routes, the rules, the security groups against ETH1 of that workspace. You'll see it if you go to the EC2 console under Elastic Network Interfaces. You'll see those secondary network interface devices for each of your workspaces in that console view. So just to kind of recap how the service works, when the user first authenticates, there's a call out over 443 out to the internet. That'll hit the auth gateway. The auth gateway passes that to the AD connector, which then connects to the AD environment either over the direct connect or in the case that we've built out here in EC2. It'll also, if you've enabled MFA, it's going to make the same call again, decides where to go based on where you've actually deployed your Radius servers. When that authentication is successful, it'll actually open the connection between the streaming gateway. The streaming gateway will open the connection between your client and the workspace. So now you're connected over port 4172 for the actual PCOIP streaming protocol between the end user's system, the physical device they're using to run workspaces, and the end user's workspace. All user traffic runs over ETH1. That's, again, the device that's in your VPC. All service traffic runs over ETH0. That's the network device that's in the managed VPC. Mm-hmm. So the main things to remember: authentication is initially via 443 to the Workspaces Authentication Gateway. Now, we support proxies in the Workspaces client for that authentication traffic, but we don't support authenticating proxies. And once you've actually made that connection, the connection has to be direct. You can't proxy the PCOIP traffic. And then we have network health check servers. We'll show those actually in a little bit more information about those as we go into the client in a moment here. Oh, right there. So you see here kind of a blown up version of the Workspaces client. The green check marks in the health check, you see a green check mark on the bottom left-hand box, shows that everything is passed. Individual network checks that we do as part of the client to show the health and reachability of the service, right? It's possible that you'll actually get a red X on the TCP and UDP 4172 port checks, but still be able to connect to the service if you've read our admin guide and opened network connectivity to 4172 to the gateway ranges that are in your region. The health check servers are actually in general EC2 IP ranges. So you can open access to 4172 for those specific ports if you want to get rid of the red X. But the main thing is you have to have the service open to the PCOIP gateway ranges. And the client right now, because of the health check servers existing as standard EC2 instances, you can't create a single rule that makes that happen on your firewall. All right. So with that, I'm going to hand it back to Justin in the hopes that he says routes some more.
So let's kind of pull this all together now, right? So a couple of things that we need to cover here. So we're going to talk about the instead architecture that we've kind of pulled together for this use case, right? Remember, we've gone ahead and we've created a dedicated account. Okay, so a dedicated account for Workspaces. We've gone and this customer has got a shared services VPC running in a different account where they're sharing out Active Directory in this case with DNS integrated and a few other items. Okay. We've spoken briefly about deploying Workspaces, and we'll cover a piece of that in a moment. Yeah. Now, part of deploying Workspaces, well, I can do all of this via the console, but you can also programmatically do this. A lot of customers I have, at least at scale, will be looking at some kind of service portal where their users can request a workspace. There's a workflow behind there for authorization. Yeah? And at the end of it, it needs to send off an API call to create the workspace. But in return, I need to find out what workspace has been created, and I need to find out the reg code that's associated with the Active Directory connector, especially if I've got more than one. Okay? So we're going to show you that. Then we're going to have a quick look, and we'll show you logging in with the client. I mean, most of you should have seen this before, but we'll just kind of pull it all together. Show you pieces around the health checks, how this all works. We're going to talk about logging in with the MFA, so we'll actually show this running. Then we're going to be on the desktop, and we're going to take a look at group policy results. So we're just going to confirm that, one, we're using the local Active Directory, which it should show, and of course that the policies have been applied that we've now gone and created. Okay? Specifically, what we're looking for is the Workspaces default policy, okay, that we've created. Then we're going to go into the arbitrary log and actually show you that actually the encryption's been set as it's required. Okay? Just kind of just pulls it all together. Now, what you may have noticed here is, as we said earlier, this is the small portion of the demo, and it's actually the small portion of the desktop, right? The desktop piece itself is the smaller part of the overall service. To have this working correctly for your organization, be that small or large, you need to follow these concepts, okay? So the end state architecture as we kind of built here looks like this, okay? So you can see here we have our customer data center at the bottom, okay? And we have a bunch of VPCs, right? So you can see here we have an application VPC and a shared services VPC. These are in separate accounts, okay? And we have our Workspaces account. Now, unlike the demo environment where I don't have direct connect in place, here you can see we've actually defined the direct connect. So each one of those is a virtual gateway, okay? And we have peering between each of the different connections. So I have peering from my Workspaces account into my shared services for directory services, okay? And I've also got peering, for example, between my application VPC and the shared services. Again, Windows systems that need to authenticate. I haven't drawn it on here, but you can do multiple connections. So I can do a VPC peer from my Workspaces to the application VPC, therefore enabling traffic to run local and not always down through the direct connect. Okay? So promised you an example. Here's an example running through. So if you're using some kind of portal or automation to create workspaces based on a workflow, these are kind of what you're going to use from the PowerShell command net. So new workspace, you're going to say it's a workspace. We haven't really covered the concept of bundles and images. We'll kind of expect that you understand that at this point. Okay? So here we're going to give the bundle ID that's required, and we're going to specify the directory. So remember, we're going to specify which directory we're using for which user. Okay? That will then go off and generate and spin up the workspace. Remember, it can take about 20 minutes. Okay? Once it's spun up, again, I need to find out what the reg code is. Now, to do this, I need two different sets of commands. The first one is, and I've done this as a very simple example, I'm using a variable, and I've called this directory, and I'm saying go and get me the directory ID and the user ID, okay, the username, and plug it from get workspace command and plug this into the variable. Then I'm going to use that variable in the second command, which is get workspace directories, to find the registration code. Okay, so this way I'm going and finding which directory do I need to talk to, so I have to find out my user ID, which directory it's associated with, and then go in and find what the reg code is associated with the directory. And these are just two very simple ways of doing this. And okay, so you can see down the bottom here, this is the reg code that we need, and we'll be showing you. Okay. So with that, let's kind of plug back into the screen here. So just flip. So as you can see here, so I'm back on my desktop. In this case, I'm just going to start up my Amazon Workspaces client. So as we said before, so for those who haven't seen this, we're going to go in here to manage registrations. We're going to enter the registration code. Remember the same registration code here. We click register. Okay. Remember what we said earlier. At the bottom of the screen here, you can see we have this network icon, and it's green, which means for us, luckily, we're on a public Wi-Fi here, and everything is enabled, right? So you can see here the network connections are there. I have internet connections. The registration service is available. The health check servers have returned healthy, okay? Remember, as my colleague said, if they're red, but you have allocated the gateway ranges, which are regional, then you will still be able to connect to the service. This is very useful for your help desk staff, right, to find out where things are and if there's connectivity issues. Okay? So let's go ahead and log in. So I'm going to log in with my user account, my password, and here's where I'm going to enter my MFA. So we'll just wait for that to log in. Not quite sure how the network is here. There we go.
Let's just hope we're not patching.
Yeah, we're not. So let's just move this to full screen. So I'm not sure if you saw this, but 2 days ago, I think it was 2 days, right, Jeff? Yep. Yeah. So we released Windows 10 for Workspaces, right? So this is now available in the console. You can now deploy Windows 10 to your users. Previously, this was a Windows, so you can still do this. There's still a Windows Server 2008 with a Windows 7 skin. Just to be fair, Windows 2012, yeah. This, for example, is Windows 2016 with the Windows 10 experience. And again, they're both the same kernel, so you shouldn't have any issues with applications. Okay? So inside of here, as we said before, what we want to do is run, did I do that one? Hold on. So first thing we want to do, we're going to have a look at GP result. Now, this is a little small, so I'll expand the screen. Hopefully this works. Give me a couple of seconds. Just scroll up. And hopefully. Aha. Right. Hopefully that comes up. So here you can see, based on our design, that we've actually responded against, in this case, AD03. Remember in our setup, we had AD1 and 2, which was on-premise, and 3 and 4 are in the cloud. Okay? So you can see we've actually responded from this. This is based on the sites and services we're set up. You can also see here that the applied group policies, so you can see here we have the Workspaces machine policy has been applied, okay, exactly as we'd expect. Okay? Now the other thing that we mentioned is we want to look and see the encryption that's been used. Okay? So on any machine that's running Workspaces, to find this is actually located in here. So it's located, oh, hold on, sorry. So you can see this is located in C program data, Teradici, PCIP agents, logs. Okay? And the log you're looking for is the arbiter log, okay, which is this one here. So when you open this, you should then see this one here. And this is what you're looking for. So here you can see that the SSL connection that's been negotiated, and can you see that okay? Yeah. So you can see the SSO, the cipher that's being used is the AES-256. So it's the setting that we enabled by not enabling it.
Right, we disabled the other settings. There was a lot of clicking involved. Right?
Yeah.
We ended up with only enabling the AES-256 by disabling everything else.
Exactly. So you can see now we have this. So this, as I said, this is the last part of the puzzle. I mean, it's a very, very simple demo, but this kind of pulls it all together, shows that we've got the directory configured correctly, sites and services set up, that networking is running, that the group policies are being applied that we need, that the recommended security settings from us to go to AES-256 are all configured. So with that, let's go back to here. So with that, just want to thank you all for attending the session. Hopefully you gained something from this. This will be online, of course, so you can view it later. Please remember to complete the evaluations. Okay, it's really important for us.
All right.
Thank you, guys.
Thank you very much for your interest.